All right, here we go. All right, so you guys know about comments, how to write comments in code. I'm just, for some reason, they're bringing it all up again right here, but I think it's because they bring up this thing called preconditions. So here's the deal. Comments make your programming code easier to read. Java ignores the comments, and I mean, it doesn't matter what's in them. It doesn't affect how your program runs. So one way to do comments is to just do 2 slashes at the start of a line, and then that whole line, even if it wraps around, that whole line is considered a comment, and Java ignores it. And then another way to do comments is to put a block of code between. It's a /* star and then a */ So anything, it doesn't matter how many lines happen between those things, that'll be all considered a comment. So anyway, I think you've seen that before. That's no big deal. And now there's this thing called a precondition. And a precondition is a requirement, something that has to be true before you run some other code. So take a look at this example. I have an example that's going to return these 2 numbers divided by each other. And you could say a precondition for this code is that the variable b is not 0, right? Because you can't divide by 0. So if you wrote a program that that was going to divide 2 numbers, and one of them could sometimes be 0, you would want to add a check, because if your program ever tried to divide by 0, it would just crash, and that would be bad for whoever was going to be using your program. So for this very simple set of code, you could say a precondition for this code executing successfully is that b not be 0. Let's look at another example. Here's a method. So I just made this up yesterday. It's let's take a look and see if we can figure out what it's doing. I mean, I admit it's not trivial. So I'll tell you what it's doing. It's taking part of string 1 and checking if that's equal to all of string 2. So it's basically, furthermore, it's checking if the first characters of string 1 are equal to string 2. So I'm wondering if anyone would like to take a stab on what would be a precondition for this code to successfully run. So this code won't always successfully run. Anyone? What would have to be true for this code to be able to run? What if we had str1 equals donut and str2 equals do? Would that work? Would this code execute? Think so? I think so. Yeah. What if we turned it around and string 1 was do and string 2 was donut? Would this code successfully run? I mean, it's just trying to return a true or a false. So, so someone said string 2 has to occur in string 1. That's not required, because see, we're returning a Boolean. We're going to return true or false. So it's okay if string 2 doesn't occur. And now's the time for one of you to at least say in your mind, if you care so much, Mercedes, why don't you tell us what the precondition is? Well, I will tell you what the precondition is. The precondition is string 2 has to be shorter than string 1. Otherwise, this code would crash. Because if you look back here, well, on either one, we're going from 0 to however long string 2 is. And then we're checking if that's equal to string 2. So back to my little example here, if we were trying to do substring on string 1 and we were trying to go 0 to 5, that's what we would be doing, because donut is, the way I spelled it here anyway, is 5 characters long. And so if we tried to get character, if we did str1 substring 0, 5, it would crash. And that's what would be happening right here if we just use the length of string 2. So you could say a precondition for this code to run successfully would be that string 2 has to be less than or equal to the length of string 1. And so you could say it like this: 0 less than or equal to string 2 length less than or equal to string 1 length. Yeah, so thanks, Brian. You said it. I appreciate it. As a heads up, there's 3 of these precondition problems. We're doing some AP classroom work today. They're all basically saying what has to be true for this code to not crash, for this code to do what we say it's supposed to do. And sometimes you have to look at the code and figure out what they're even trying to do. Anyway, it's not a big deal. Precondition is just what it says, a precondition. What would have to be true here for this thing to work? And since those problems are multiple choice, you'll be able to see you'll be able to see, what potential answers are. All right, so that's it for 5.3, which is comments and preconditions. And now we're going to talk about 5.4 and 5.5. So take a look over here. So Java is designed from the ground up as an object-oriented programming environment. And classes are the objects. And Java supports this thing called encapsulation. And that's where you can have an object that manages its own self inside. So you as a programmer can use objects even if you don't know how they work on the inside. Like, let's take, for example, system.out.println. We don't really know, we don't have access to that code, but we know how to use it. We know we can call print and we can throw things at it and things will happen. We don't have to know the internal workings of it. Or the scanner, that's probably a better example, the scanner. We create a scanner and then we can say, hey, next line or next int or next double, right? But we don't know how scanner works on the inside. It could be 5 lines of code, it could be 1,000 lines of code. We're letting scanner manage itself. So in a way, scanner is encapsulated and it does its own, we're happy to let it do what it does. We don't have to know, we just know how to use it. When we write our own classes, we make variables or methods private that we want to be managing inside of the class, that we want to take care of ourselves. And that's part of this philosophy of object-oriented programming. So I'm going to get specific now. Going back to an imagined rectangle class, there might be, this is a method that says set width, and a rectangle class might let you change the width or height of a rectangle after you create it. And this code checks. It says, hey, if you're going to set the width to a new number, we're going to make sure that it's at least positive before we let you do that. And I think you'd agree, if you were going to have a rectangle object, you wouldn't want to let someone create a rectangle with a negative width. I mean, it'd be intellectually interesting to do, but that wouldn't be much of a real rectangle. So what we do, we have these methods in our classes not always, but sometimes. They're called accessor and mutator methods. They let us get access to what is otherwise private information. And the reason you would do this normally is, well, it's just good form in Java programming, but also it allows us to control how someone else using our class would change information. So this is an example where instead of just saying set width and then inside saying width equals W, we're saying, hey, let's only set the width to the new number if it's a positive number, because that otherwise it doesn't make sense. And here I've made a shirt class. I'm just showing you one method in it where it does a quick check and it only lets you set the color of the shirt if the color is pink, red, or blue. That's just because this particular model of shirt has only 3 colors. And so if you tried to set the color of this shirt to yellow, it just wouldn't do anything. It just ignores your request. So this is called data validation, where you, when you write a class, add some checks in there and you control, you kind of funnel all the data access and data changing through these accessor and mutator methods. So now I'm defining them. An accessor method, sometimes called a getter method, gives you access to the private variable information. And a mutator or a setter method allows other people, other code to change information inside of a class. The variables that we're saying are private, normally you can't just change them directly. So here's an example of an accessor method. Again, for say the rectangle, it just, hey, public int getWidth, return width. It's giving us access to one of the private variables. And then a mutator method example, I already showed you this one with a check. This is it without a check. It's just saying, hey, fine, you sent me a new width, I'm going to set it to that. Now, accessor methods will have a return type like int, double, string. Mutator methods usually are void because you're just sending information over, trying to change something inside of the class. Any questions? I know I'm just sort of barreling forward. You've already been writing methods. Go ahead.
Could you go back to the last slide? I didn't get the definition for the mutator.
Yeah, mutator methods, sometimes called setter methods, just change or set the value of a variable inside of a class. So what I do is I think about it like this: accessing it gives you access to what is otherwise private and hidden. And then mutate means to change something. So just think, oh, does this method that, I'll be asking you, is this an accessor method or a mutator method or neither? And then you could say, oh, well, that's a mutator method because I see it's changing one of the internal variables. And this slide deck is on our first assignment or our next assignment for today. So, so again, the accessor method just is returning a value, and a mutator method is setting a value of some kind. Now I have, so accessor and mutator methods allow us as the programmers to control who can see or change information in a class. And this is called encapsulation. So we'll think of it as a way for us as the designers of a program to protect the internals of the class from outside meddling. So ideally, as I said before, in Java, we as the programmers, if we want to use a class, we don't have to know how somebody wrote the class. We just know what we're allowed to do. So like, again, with the scanner object, we know we're allowed to create a scanner, and then we know how to use a scanner to get information from the user. We don't have to know what's going on inside. And in fact, Java, made by Oracle, they could change the scanner class. They could fix a bug in scanner. They could redesign some of the internals of scanner. We don't care as long as they say, hey, it's still going to support next int, next line, that sort of thing. We don't need to know what's going on inside. That's one of the powerful parts of object-oriented programming. And I mentioned here on the text on the screen, when we started this unit, I showed you a rectangle class, a circle class, the frog class, the book class, and but let's look at rectangle and circle. They both have a get area method, and we don't need to know how you find the area of a rectangle or how you find the area of a circle. We just know, hey, for these shapes we can call get area, and then our creations will tell us what the area is. I have a little example here. I want to show you. So look at the screen share. I've got a little rectangle class here, somewhat simplified. It just has a constructor and then a get area, get width, and a get height. Notice right here, I made the width variable not private. So I wanted to show you how this works. So I'm going to run my little sample code. Pretty sure this will run. So let's look at what my code is doing. I'm making a rectangle. Rectangle R equals new rectangle 4x5. So this is going to be a 4x5 rectangle. And then on line 4 of my code here, this is something you haven't seen before. Notice this says print the word width and then print r.width. So check this out. That's how you can access, if somebody makes a variable in a class and doesn't make it private, you can get it by doing r dot and then the variable name. So that's what on my output here, it's printing out the width right there. Now watch, if I try to get the height, I'm gonna try to print the height, and I'll run that code. It's gonna say we don't have access to that. See right here in my error, it says height has private access in rectangle, and that's because right here, see it says private int height. So I'll remove that line, and in a minute I'll make width private again. But check this out. As long as width is not private, watch this. I can say r.width, and I can say is equal 1,000. I can just change the width here. One little line of code. Boom. Now instead of having an area of 20, this will have an area of 5,000. I'm just showing you this. So and watch. I can say, hey, I'm going to make the width -17. What? This is me as some other programmer using the rectangle class in a nefarious way. Like, if you wanted to write a robust, a well put together and dependable rectangle class, you'd probably want to have it check and make sure none of the length or width were negative. And to do that, you would normally, make them private so that nobody can mess with your variables. So you'll see now that I made the width private, I run this, it's gonna not compile or run because I'm trying to print r.width and I'm trying to set the width to something. So instead of that, I did have a get width method. So we can that's why we make that sort of thing. You might want the width of something as a separate thing you could call. So I fixed it now. I'm using the getWidth method. That's an accessor method, right? This is how you use it. The name of your object dot and then getWidth with the empty parentheses here, or get area. So technically, getWidth is an accessor method and getHeight is an accessor method. And a get area isn't really, because it's returning width times height, which isn't, uniquely, it's not one of the variables that we access. This class doesn't have any mutator methods. If we wanted to, we could write one that would allow you to set the width. I guess I might as well. I had a little list of what I wanted to do. Okay. Oh, and I wanted to add myself a mutator method. So let's go ahead and do it. Let's add a public void set width. And in here we have int w. And I'm going to say if w greater than 0, width equals w. And I'm not doing anything if it's not greater than, because it just doesn't matter. So then up here, I'm gonna go ahead and do it. R dot set width. I'm gonna try setting it to -5 or -17 like I did before, and we'll see that it's just not gonna do it. It still prints the width as 4 because it ignored it, and because that's not a valid. Now, if I make it +17, then we'll have an area of 85 because 5 times 17 is 85. So the takeaways here, I wanted you to see how if you didn't make the class variables private, then you could access them directly up here in other code. You're not supposed to be doing this. I was just doing a demonstration. So this is public, and I forget. I don't think I gave you this. But I can I'll post it on the chat if you want to look at it. But no, I just wanted you to be looking at it. But there it is on the chat if you want to open it up and look at it. I'm done with that now. So a couple more things, everybody. Back to my screen share, the notes. So most of the time, we make all methods in our classes public. You know, like public int getWidth or public void setWidth. You can, sometimes you would have a class that would have a private method. If you do, that means that method can only be called from inside of that class. So that would be a method that maybe would do something that helps you out in your code that you didn't want other people to be able to access. So sometimes you'll hear this being called a helper method. So right here, I made a helper method. Again, back to this mythical shirt class. Notice shirt just has one variable, the color. And when you make a new shirt, public shirt, you send over a color. And now instead of having code checking about the colors in the constructor, I'm just calling inside of the constructor, I'm calling the set color method, which is private. So private void set color, and you send over a color, and it's checking, hey, if this color that is pink or blue, go ahead and set it. Otherwise, set it to pink. So this is an example of a helper method. See, this is private, which means someone else in other code couldn't say, hey, I'm going to make a shirt and I'm going to call set color. Because I wrote this as private, the only code that can call set color is some other code inside of the shirt class. I'll be honest, it's very rare that you would need to make a method private inside of a class. But again, on our 15 AP classroom problems today, one of them has to do with a helper method. So I wanted you to have seen it and not just go, oh my gosh, what are they talking about? So a helper method in this case is just something that your class uses internally, like in this example, that other people can't call, that you can't call from outside of the class. Now, you will practice. I've got 2 assignments please finish the warm-up if you haven't already, but then we have 2 assignments for the rest of our class period today. One is a superhero class. I'll post it right now. Please get that done today. And then the other is I'm asking you to do the progress check part A for unit 5. There's 15 problems, and I'm saying, can you finish that by Thursday at 5? I mean, you might finish it today. As usual, I posted a video. I will post a video in a few minutes of me doing all those problems, so you'll be able to you could do it as you go along, or you could watch the video after you're done. Yeah, I'm going to make breakout rooms that let you do work. I'm posting the slide deck right now. So right now I'm posting first the superhero, and then it'll take me a few minutes to post the AP classroom part because I got to log into there. Any questions? I think I'll stop.